Hi, welcome everyone to today's panel discussion on planning and procurement of an EMIS. I'm really excited for this one. We have some great experts and great experience in the room today. Before we jump into that, we do have Asia Staples from the IESO here to talk a little bit about some save on energy incentives that are available both for EMIS and for other projects that you might be thinking about or planning. So, Asia?
Thanks, Jay. I'm very happy to be here today. Really looking forward to the panel. It's going to be a great hour. I'm just going to take a minute to just go over some Save on Energy programming that may be of interest to you who are attending today. If you're not already aware, we do offer an EMIS incentive through our Expanded Energy Management Program. So it's up to 50% of the project cost. You can see there's two tiers of incentives there based on your annual consumption in gigajoules. So this includes all fuel. We're very grateful to Natural Resources Canada and their Green Industrial Facilities and Manufacturing Fund for financially supporting and allowing us to have this offer. What's really important to know is that this funding ends March 2027. So if you are thinking of purchasing and installing an EMIS, and you are interested in this incentive, definitely get in touch as soon as possible to ensure you can secure the funding. You can email us at sem@ieso.ca. Happy to have a conversation, answer any questions, and assist you in an application process. And then I just want to talk briefly also about our Accelerate program. This is our new industrial offering that launched last fall. And after extensive stakeholder consultation regarding our last iteration of this program, there's some new improvements. We do offer project feasibility study funding, so that is available. And for projects, the incentive has been increased to $300 per megawatt hour. This is up to 75% of eligible costs, up to $15 million. So if you're thinking about capital projects, larger projects, you can be in touch with us about these. We offer comprehensive support. So we have technical reviewers who can support you with M&B, the application process. And if you go to the next page, Jay, you can see the contact information. You can email us. If you just want to have a conversation about what kind of projects you're looking to do and if they might be eligible, we're happy to do that as well. So thank you for the time. I'll pass it back to you, Jay.
Thanks, Asia. We do have a question in the chat about if there's any conditions on the EMIS incentives and if it does it depend on the amount of energy savings. And I think there's facility like total annual energy consumption as like minimum thresholds, but are there any other conditions around that they should be aware of?
It's up to 50% of the project costs according to the two tiers. So yes, if you're over 400,000 gigajoules, it can be up to 250,000. And if it's under, it's up to 50,000 depending on your costs. And there is no measurement and verification requirement as part of that offering.
Okay, so it's not limited by savings, more on just total energy that's being consumed there.
That's right.
Great. All right, thanks, Asia. If anyone else does have questions about those programs, I believe Asia is hanging around for a bit for this, so please type those into the chat as we go. And now we'll be moving on to our panel discussion. So we have three excellent panelists today. We have Plamen Notov from the Director of E2F Systems, Anissa Rambali from Durez Canada, and Dave Fox from Quantify Environmental. I'm really excited to have this expertise on here, both from consultants and vendors, and also the end users who have implemented energy management information systems. So as we go through the panel discussions, they're each going to have sort of a short presentation up front, and then we're going to have a good chunk of time for question and answer afterwards. But if you think of questions as we go through, please feel free to put them into the chat, and we'll make sure to get to them after those presentations. All right. So thanks, everyone. Thanks to the three of you for joining us today. And Plamen, do you want to start off?
Sure. Thank you very much, Jay, and very happy to be here. Let me put my timer on here so I don't eat up all the time today. Quick intro. So my name is Plamen Notov, Director at E2F Systems, also supporting the Association of Energy Engineers as VP of the Southwestern Ontario chapter. So if you're an energy management professional in Southwestern Ontario, please do connect. I'm hiding under the elusive name of Plamen Notov on LinkedIn. There's not too many of us, so feel free to find me there. But yeah, really excited to dive into this and talk about EMIS. Having had a chance to look through the slides up ahead that Anissa and Dave will be sharing, there's some really great information with hardware photos, technical specs, case studies, real life case studies that are just going to be very valuable to anybody that's on here. For my portion of the presentation, I thought it'd be important to focus more on the very beginning, on the planning side, because as energy managers, and I'm assuming many of us here are energy managers, and we all see the value of energy management information systems, the value of having more data, good data, reliable data, the actionable data. But the folks holding the checkbook, our CFOs, our general managers, may not always have that same understanding. So my presentation, my few minutes will be focused mainly on that. If you're past that point, please stick around because we've got some great case studies and so coming up with the other two panelists. So with that said, if you're thinking about EMIS, start with why. What is your why, right? And the real question here should be, what is the problem that you're solving for? Is there a gap? Is there something else? Because when you go to a CFO, implementing EMIS is basically a cost. There's hardware, there's software, great. There's zero ROI just on the actual system itself. So everything else that you can do with it, you have to be able to articulate it. So be clear on what that why is and understand some of those metrics. And moving on, again, unless you're holding and you're making this decision, even internally, whether you're a consultant or internal energy manager, you'll have to sell this project. And I want to see more of these projects be sold because I strongly believe in this value. So this project is likely going to be competing with other projects in your company, whether that's other energy projects or other revenue projects. So be clear and articulate, again, the problem, the risk of inaction, right? If you don't do an EMIS, what are you risking today? And maybe this will help you also generate revenue. Like be clear on some of those items so that way this project becomes easier to sell as you kind of move it up the chain. The slide here where it says more data and more software does not equal more savings or revenues, we can get lost in that because as energy managers, we love more data and we can do tons with it. But the reality is that a lot of folks in management, CFOs and so on, we're drowning in data. We're getting too many notifications. And the last thing that you want is just to sell, great, we're going to have lots of data to go by because that data doesn't always translate into solving a real problem or generating revenue. And we've seen this before, just as an example, walking into a facility and seeing, $15,000-$20,000 worth of high quality power meters just sitting somewhere in a room, not being used at all, right? Because it was the why wasn't identified, it wasn't solving the problem, and there was no continual process. So moving on, as you're planning this and as you've identified the why and you're starting to move this up the chain and starting to think about, okay, how am I going to present this? Spend more time on the problem than the actual solution, right? Focus really deeply on the problem that you're really going to solve here. And one of the tips that I would say is understand your company's pressing objectives. So today, this quarter, this fiscal year, is your organization focused on sustainability? Is it have a higher priority on cost containment? Is there a revenue generation? Is there a building expansion perhaps happening? Many of these things fall into the scope of what your EMIS can do. But if you can align it with the pressing current high-ranking objectives that your management team and company has, you have a much better shot of getting this getting the system done. And one other thing, if you're doing this internally, talk to folks. Has anybody looked at this before? Have you implemented a system before? Has there any metering been done before? Where did it land? What happened? Right? Important information as you move this up. Again, the objective here is to get these projects moving. Okay, and moving on. So as you're starting to think through these things and talking to folks in the organization, start to clearly articulate what the potential ROIs can be and start to put some figures around what the risks of inaction can be as well, right? So your EMIS, for it to get a passing grade and to get moved beyond, just the consideration phase or something that gets done at some point in the future, it has to be an enabler of something substantial. And the good news is that in almost all cases, it is an enabler of something substantial. So consider in real terms what it is going to do beyond the obvious. Think beyond just the week, the lights being on left on during the weekend when nobody was there, right? Put yourself in the decision maker's shoes. Is this a winning project? And some simple questions. If you're looking at an industrial facility, we've seen cases where employees used to clean off their work boots using their compressed air, right? Does EMIS solve that? But it can point in the right direction that something's not being used the way it was intended. And speaking of compressed air, just small leaks in a compressed air system can cost you thousands of dollars per day. So when you have that conversation with the CFO, be ready to make statements like, hey, we might actually be blowing money into the air. How do you feel about that? So very, very real ideas. Moving on to a couple of other sort of applications that you can consider. And again, all places are different. Understanding your objective, matters the most. But some ideas here: have you made sustainability commitments? Your EMIS can help you track some of the progress from the energy perspective. Can it empower new revenue streams? Can it optimize how you participate in things like demand response or the Global Adjustment ICI program? These are high value items that can really be empowered and improved using in a properly implemented energy management system. Demand spikes, right? Are you starting up all your machinery within 1 hour or within a short interval and you're spiking your demand, right? Again, these are things that EMIS can help you articulate. And we talked about gas leaks, air leaks, and so on. So a few tips and ideas. Think about what's most important for your facility and be ready to articulate that. Moving on to one of the subsets of EMIS, Jay, if you want to move on to the next slide. So for example, here in Windsor a few years ago, and this just comes to mind as something that's relevant. There was a fire, an electrical fire that caused a multi-residential building to burn down. Hundreds of people lost their homes. A few remained homeless for a long time after that. Millions in damages. I'm not necessarily saying that an EMIS would have prevented it, but in many cases, having an effective energy monitoring system will point you towards a potential fault much earlier than when it physically manifests. So in this case, the physical manifestation was the smell of smoke followed by fire in a catastrophic event. And having a properly set up EMIS can and should act as a preventative measure in many cases. Thinking about advanced machinery, advanced manufacturing, again, motors, you can at least get an idea to send somebody to look into an unusual specification, and just having somebody look in a certain way can lead to big headaches and lots of costly things avoided down the line. So think about the proactive maintenance side. All right, and when you're presenting this, keep it simple. Focus on the main problems that you're solving, and when you're talking to your vendors, if you're just starting off, don't try to do everything at once. Start simple, get something implemented, and have a role plan of what the future looks like. How do you add more metering? What does that process look like? If you're speaking with a vendor, you may even want to consider, hey, what happens if I install your hardware and I have your solution, but in 3 years I want to change vendors? What happens to the data? Have some of these conversations up front, right? Like nobody wants to think about that, but that's how it works. And we should have these conversations early on. All right, and the last slide, it's the year 2026. I don't think any conversation can be had without mentioning the word AI. As energy managers, AI can be extremely powerful, right? We're not, it's not about outsourcing our own jobs, but it's about becoming more effective. So simple things. Think about how you're going to connect your data. Eventually, you can ask AI, what was my peak demand in July 2023? What was my cost of energy between August and September of 2025? And you can get these answers very quickly, along with doing some more advanced modeling. So consider that early on so you can build for it as the capabilities expand. And yeah, that's it from my end. And I'll pass it over to, I believe it's Anissa.
Yeah, thanks, Clement. And yeah, Anissa, you're up next. And just a
Thanks,
reminder
Jay.
for if anyone does have any questions, please do put them into the chat, and we'll get to them in the Q&A period.
Okay, great. So I'm Anissa Rambali. I work as the quality manager at Duraz Canada. So Duraz is a plastics manufacturing company located in Fort Erie, and I have been there just over 10 years with some experience in engineering and some in quality, and I've been a part of the energy team for my entire time here. So just on the agenda, we're hoping to look at defining the scope for metering, selection of instrumentation, and integration to an EMIS system. So looking at the scope for metering. So I would say this was driven mainly by our manufacturing process. So it was specific to us. Our site is separated into 2 molding compound units, 2 resin production units, and we also have auxiliary units such as boilers, air compressors, warehouse, maintenance buildings. So the first step was determining which utilities were interested in metering. In the end, we zeroed in on 4 of them. So compressed air, natural gas, steam, and electricity. The next step we took was to look at the physical plant layout to determine where we would install these meters. So I'll just explain what you're looking at. So I would say the green boxes are our production buildings. So building 3, 4, 5, and 6. The buildings in orange represent the auxiliary buildings, like I mentioned. So our maintenance, admin, and warehouse. And lastly, the building 10 indicates where our boiler and air compressor is located. So as you can see from the diagram, most of the lines branch from building 10, and we strategically position those meters on those lines to capture the production buildings. So the meters installed for our project, we installed 4 steam meters, 9 air meters, and a couple more meters were already existing at our plant. So 4 gas meters and 11 electrical meters. So at the time we implemented this project was in 2015, so a while ago, and it cost $100,000 at that time. And our plant applied for an incentive to cover the project cost, and that incentive covered almost half of the cost. So it was a significant help to us in terms of the payback. So moving on to the selection of instrumentation. So the air and steam meters, sourcing those. For the steam meters, instrumentation was recommended by our vendor who completes our annual steam trap survey. So the vendor was chosen based on positive history with the plant and experience with the survey results. I would say our air meters were chosen based on a few instrumentation companies that we worked with in the past. They had some recommendations. And then applications were reviewed by these vendors with us in terms of like steam, air pressure, the estimated flow rate, pipe sizes, so whatever we knew at the time from our systems, and then compatibility with our PLC, so our programmable logic controller. The instruments are selected based on data accuracy, ease of compatibility, and maintenance, in addition to the cost. For the electrical and gas meters, like I mentioned, these meters already existed at the plant. So we worked with an electrician to determine whether the data from the meter could be extracted, and the sort of wiring to our PLC. For the gas meters, we did contact our gas supplier to determine how to extract that data. So in that case, additional instrumentation and wiring was needed. Looking lastly at the integration to the EMIS platform. So we worked with our plant integration vendor to extract the data from the instrumentation and really discuss or determine the way that we would like the data to be displayed for further analysis. So we chose that vendor again based on positive history with the plant and in-depth experience with the architecture of our system. So in terms of the business side and the process side. So the snip shows our actual EMIS system. So this is located on the business side. The actual instrumentation was on the process side. So it was really pulling that data to this other end. Three key features of the EMIS system I'd like to highlight. Ad hoc utility, which is essentially hourly, daily, weekly usage. So really zoomed in data. Monthly trends, as it implies the usage for that month. And then lastly, building 10's utility efficiency. So that's where our air compressor and steam boilers are located. So just in terms of efficiency. I just wanted to highlight, just going into the EMIS system, specifically building for electrical. So this is what the EMIS system looks like on our end. As you can see, it shows the different production buildings. So building 3, 4, 5, 6, and then total plant. The utility that we chose in terms of electricity, gas, steam, and air. We could choose particular date ranges. The monthly trends default to 1 year, but say you're interested in 2 years, that's also possible to look at. We also have the ability to extract that data to Excel, say for further analysis or like financial planning on the usage in for the next year. The actual graph shows the red is electrical usage, blue is pounds, so our finished good pounds produced, and the green graph shows the usage per pound. So this is normalized data. I would say we really focus on the green graph because it is normalized. You can't just look at the usage, it really needs to be linked to what was produced. So in terms of that graph, we look for steady or a reduction, which would indicate efficiency. An increase would indicate a need for attention. So in that case, we linked those 2 months, May to June. We did experience some equipment issues and related troubleshooting on the plant end. So I would say the data is important, but really making the link to what's happening in the process is key. I just want to highlight like another feature. So in terms of this one, it's building 3 gas. So as you can see, the spikes represent on our end the number of batches made per week. Building 3 is our resin production building, and it uses gas to produce gas essentially for hot oil, which generates our resin in our reactors. So what we were looking for here is just the usage to make sure it's normal and steady. A spike would indicate like longer cycle times. And then what's key is the weekend shutdowns. So as you can see, it's 0 on the weekends. We are down on the weekends. Say we did see some sort of value, it could indicate that something was left on. And the last feature are building 10 utility efficiency. So by definition, efficiency is the energy output versus the energy consumed. So in the cases of the boiler and air compressor, it's the steam versus the gas used, and the compressed air versus the electricity used for that air compressor. So these graphs show a 1-year period. The graph on the top, the gray shows the steam produced, purple shows the gas consumed related to the steam produced, and then the green is the efficiency. Same thing with the air compressor. Blue is the air produced, red the kilowatt hours consumed, and the efficiency is the division of the two. So for the steam boiler, there's a seasonal impact as our plant uses steam for heating and also for our process. I would say the efficiency, like of boat units, may increase after scheduled maintenance. So that's something to observe. And a decrease in efficiency would indicate for the air compressor, maybe like leaks throughout the plant. Next slide. And lastly, I just wanted to show the benefits of metering. So the air and steam meters can have appropriate alarm set points. This just shows an actual leak that occurred in our process. So it was a dust collector pilot valve. As you can see, the flow rate was 12 meters cubed per minute. It doubled to 24. And then after it was repaired, it went back to 12. So say that leak was undetected for a week, it could cost us up to $1,600 Canadian. So just the benefits of the metering for early detection, you can have appropriate alarm limits. And just to recap, I talked about defining the scope for metering, selection of instrumentation, and integration to an EMIS platform.
Thanks, Anissa. Thanks so much for that. Clement, there is a question in the chat for you, and I'm going to save Deepak's question for the Q&A afterwards with everyone, but Anissa, there was a question if it's possible to share any of the vendors for hardware or software that you considered or ended up using for this in the chat, if you want to answer that while we move on, if you're able to. But next up, we have Dave.
Hi, everyone. Really nice to meet everyone here. Great turnout. It's a pleasure being here talking about EMIS. It's an exciting conversation, and we're happy to be here at the table to share what we've learned with a lot of years of experience with Canadian manufacturers. I also really appreciate the way the conversation's been structured today. Great opening with Plowman of like, what is your pain point? Let's focus on that first, because like he said, you really do need to sell it internally. And if you look too broad and try to include too much, the project may not go through. So it is important to look at that initial pain point and expand from there. And then those specific examples of an EMIS in place at Anissa's plant, great practical examples of how to actually roll this out. So that's what I'm going to focus on today. I should pause. So Dave Fox, co-founder of Quantify Environmental, and we install EMIS systems. So happy to share our experience working with Canadian manufacturers. So there's a lot to take in. EMIS, you could argue, is a newer type of technology that's really come into fruition in the last 5 or 10 years with terms like Industry 4.0, Industrial IoT, that sort of things. So lots of information out there. I really want to distill my talk down into 3 points for that whole procurement sort of journey. So those 3 points are turnkey delivery, and I'm going to be using the term from pipe to project. And when I say that, I mean, I use pipe loosely. We could have a gas pipe, an air pipe, a water pipe. We could also apply that to electricity. What I'm referring to is an area of unknown data. We want to pull data off of that with hardware meters, ingest that into our software, into a platform, but ultimately find a project there and something that's going to make you some money back, reduce your overhead costs. So a financial win, a sustainability win, and make you more competitive. So that's from pipe to projects. That's the turnkey delivery. How do we get from that pipe right through to an implemented solution. And Anissa just gave some great examples of that, of how an EMIS can do that for your company. The second one I want to focus on is that plant-wide integration. And again, both speakers spoke about that. I'm going to give you some examples of how and where you can pull data from all different places in your plant where you probably already have data and you don't need to invest more money to grab it, but also areas where you may need to put new sensors in. And that whole consideration, again, Plowman mentioned it earlier, future thinking, right? If we're going to put this system in place, can we pull from many different areas and not just one sort of stream like energy or just water, for example? And the last point that kind of ties that all together, and I'm going to have some case study and some examples. Again, with Plowman mentioning that air compressor, I have a slide directly on that. But that whole idea of working with a company that's going to bring you through that entire journey, because there is a lot of parts to it. And we've learned, again, with our experience and working with Canadian manufacturers, every time you have a new contractor, that opens up a gap or a risk for the project falling apart without that seamless handoff from one to the next. Next slide, please. So that initial stage, if you're now looking for an EMIS system, treat it like an interview. Talk to all your EMIS providers and really grind them on the details, because we've seen projects fall apart when a EMIS provider doesn't have that early technical experience. And you really want to leverage the data and meters and sensors that are already at your plant. So you're going to want to ask your provider specific questions of, how do you deal with different protocols? How do you pull 4 to 20 milliamp off this meter? Can you deal with Modbus? We have multiple PLCs. Can you pull that into your system? So when you're doing this procurement, ask those specific questions. That turnkey solution, can you help us right from the beginning? And here's some examples of meters that are already in place at a lot of clients where we could pull that data off and pull it right into a new system. So next slide. And then it's the idea of where can we pull all this data from, and it starts speaking to that plant-wide integration. So you might have a bunch of blank pipes, no meters or anything in place. How can we get data off of that flow? You might, so that's on your far left there, where a brand new flow meter needs to be put in place. Another example is a PLC. So you may already have like a 50 or 80-year-old PLC that has data within it, but you just need to pull it out. So these are some considerations, like let's resurrect that data that's always been there, but we want it on a new system. Another example in the middle there is a great example, not so much directly energy related, but it's with water quality. So if you have any wastewater issues, putting in a brand new raw sensor, in this case a pH sensor, and pulling that into your EMIS system. And then lastly, your big machines, your boilers, your cooling towers, your air compressors. How can we pull data off of those? And again, plant-wide integration. So the next slide, please, Jay. It's going to give you, I would say, an unabridged list. And again, this is the whole idea of future thinking. These are just some prompts of a different way to look at your plant now and in the future. What sort of particular types of data is going to make us more competitive and really going to bring us an ROI back? Is carbon dioxide important? If your water costs, if your municipality just upped your water costs by 30%, well, right away, that's a pain point. Just focus on that 1 meter for the project. The other thing I'll mention here, a bit of a tangent, these EMIS systems are truly scalable. And so, again, in your procurement phase, a strong recommendation is start off with a small project, maybe $20,000, $30,000, where you just get one sensor and you put it on 1 meter, or you pull 1 meter live. I gave the example of a water main from a city, or I'll give you an example later of an air compressor. The reason for that is your team needs to learn the platform. You need to gain trust from the technology, but also gain trust from the service provider. And it's a lot easier to do that internally if you just invest in 1 meter, knowing that this is a scalable system. You let that run for 6 months. You gain confidence in that one sensor and the tech stack. You gain confidence in the service provider. And then you can scale, do a much larger project with 5 or 10 sensors that would cover these other areas. So next slide, one last note on that site-wide integration. Like I've mentioned, you're going to have native data in your plant that no one's looking at, or they have to walk over to a PLC and look at a small LCD screen. That's data. It's digital data that can be brought alive into an EMIS system. So, typical examples of that are your natural gas and your water main. That's data that you can pull. You might have legacy sensors, which again, I mentioned earlier, that will have different protocols that you want to start harvesting. Or you may need new instrumentation. And again, in that procurement phase, you want to know, can your service provider pull in all that existing data, but then also install new instrumentation that will work within that ecosystem you've invested in? The other part I want to mention on this, because we are tight on time, is this whole part of API. So someone before you at your facility may have already put in some sort of SCADA system, or you've already invested in Grafana or Aviva Pi. You already have digital data on a platform. We can do API exchanges, and by we, I mean EMIS systems. They can do API exchanges, so if you already have that digital data on one software platform, you can exchange it to another depending how you want to see that. Next slide, please. So here's some real world examples I'm going to throw some photos at you with. On the left, this is starting from scratch. This is a base station at a poultry facility where no system was in place. And now we're pulling data from all different sensors to get that EMIS going. In contrast, on the right there, we have a 100-year-old plant that had some elements of an EMIS system in place. And in this case, this HMI, where they wanted to pull one old EMIS into a new one and integrate them. And again, that's possible depending on the service provider you go with. Next slide, please. The last part, so I've talked about that turnkey, so from the pipe to the project. The second part was that plant-wide integration. The third part would pulls this all together and really not just saves you money, which of course is important, but really just saves you time and frustration. Is what we've seen with our experience is find an EMIS provider that can do all of that under one roof. I give a personal example of working on our house. I got one contractor to do the roof, the siding, and the eaves troughs. I didn't want to work with 3 different contractors and get them all to communicate. It's the same with an EMIS system. You have hardware, which is hard. You have software, which is also very challenging. And then you ultimately have your efficiency, financial, and sustainability projects. You will find it is way less stressful if you find one champion at one company that can take you through that whole process. Some of the horror stories we hear, well, we had one contractor install some sensors and they have no idea what the software platform is. They don't even have the right protocol. The project falls apart. People lose confidence. The most common issue, which Plowman mentioned, is you get all these streams of data. It's coming into a platform. Fantastic. Nobody's looking at it. People are ignoring alerts. You need someone who's been there with you for the journey to be informed of that data and find opportunities with you. One last point on this is the whole idea of turnover. If you have one person internally who's trying to piece this together on their own and they leave, the whole thing falls apart. If you're working with a service provider with your EMIS that's taken you through that whole journey, they can hold on to that torch for you. And when you find that replacement, easily pass it off and you don't lose all of that. So that last point, try to find a service provider that at least has knowledge on all different parts of an EMIS that can take you through it all. And the last 2 slides will just be some clear examples of the power of these EMISs. So here's one where we have single owner accountability. I like this photo. It shows it all physically in one image. We have an existing Anderson-Hauser pH meter that was already installed. But again, somewhat dead data on that sensor. Pull in a new piece of hardware, it can pull that data off and immediately display it on your platform, your software on the left there. If you have one company that can do all of that you've sourced, it makes life a lot easier. So that's kind of the physical side of it. Now I'll show you 2 screenshots of active platforms that show the real value of this. So again, Plowman's example of an air compressor. Here is a platform of a EMIS system out there where a new piece of hardware was installed in the air compressor, CT clamp, pulling that data. We now see the data on the dashboard. An opportunity was found where we have overrun periods. The project was, let's implement new run times, which significantly reduce the cost and runtime of that air compressor. And the full picture are those green numbers. How much money do we actually save? Let's prove it to our team so we earn more trust in the EMIS system and we invest and get more sensors in place and more data and more savings. I know I'm close to time, so I got one last example and then I'll pass it back to Jay. On the water side, again, pulling data off existing systems, seeing high water use, working with that team, finding opportunities and implementing it, and then seeing the post-implementation savings, which in this case, netted them $40,000 in 1 year. So last iteration, that full turnkey, the plant-wide integration, and working with a service provider that can take you through the whole journey. Thank you very much.
Great. Thanks, Dave and Anissa and Plowman. For that, we're now going to be looking at Q&A discussion. So I'll start it off, but if anyone has any questions for any of the panelists, please raise your hand or type it in the chat on there. So we start, like Anissa, it sounds like that process of figuring out what needed to be metered, that you were bringing in a lot of people who you'd worked with before, the utilities, things like that. That seemed like quite the undertaking involving all those people. I know a lot of organizations are at that point of just getting some more metering in place. How did you approach that or coordinate with everyone involved?
I would say we took it in phases, just like small chunks at a time instead of doing everything all at once. The first step was to figure out which utilities we would like to meter. So we met with myself, I was an engineering plant manager, and our energy consultants. So we just worked together to zero that in, and then we went into metering in terms of the application, line sizes, pressure, that sort of thing, and cost. Worked with engineering consultants on where to strategically install it, where it made sense, and ease of access for maintenance. And then lastly, with our integrator, in terms of how these instruments are connected. With that, we built a project cost, and we were able to submit it to corporate for approval.
Okay, so it's sort of like step by step going along, and it sounds like you have like some internal engineering department and stuff that was helping through that as well, or advising?
We use an external engineering consultant, but we do have internal engineers that help manage the processes.
Okay. And Plumman and Dave, from your perspective, like what should an organization know about their metering needs and existing systems before they start talking to an EMIS vendor or consultant? Like what information can they bring into that conversation to make it easier?
I'm going to stick to my guns on this one. Is bring your outcomes, right? Clearly define your outcomes before you get into tech and solutions and all that. Have a primary outcome. This is the first problem, most pressing problem we're looking to solve. This is our secondary, and this is what the beautiful future looks like if everything works out. And then maybe I'll pass it to Dave to talk more about the actual technical stuff.
Yeah, sure. I think, Jay, I'm going to take a different approach with your question. I would say, the question being, what should they know about their metering before going to source an EMIS? I would even argue nothing, right? And a lot of people at a plant, they're focused on their job, which may be sustainability, might be in production, might be in management. It's okay for a lot of people at a plant to know nothing about their metering, and that's okay. That's the whole point of working with an EMIS provider. So if you know nothing, don't see that as a barrier. Start calling, start researching these EMIS companies, and that's a really good filter in finding one. You'll know right away in those initial conversations if the EMIS provider can start giving you feedback about your meters and how to integrate to them. They should be the educator for your team.
Right. And there was a question in the chat about, like, while we're on the topic of metering, about commissioning. So, and so from your end, I think you responded a bit in the chat, but you want to speak a little bit in terms of, you get these meters in place, but then what steps are taken to make sure that they are accurate?
I would say for the gas and electrical meters, the data was verified using the bills. So just like the monthly usage, we sort of cross-referenced. And for the air and steam meters, I would say we just did a couple calculations to see whether the numbers made sense for what we sort of use in our process.
If I could jump in here as well.
Yeah.
Yeah, for sure. It's a critical part of a project, and that's the monitoring and verification. And it can be hard to have that capacity internally. And it should be a major part of an EMIS provider where they're putting in your meters and then they're doing constant calibration checks. So whether that's taking photos of the meter itself and comparing that to the data that's coming in, like Anissa mentioned, doing a sanity check, comparing it to your utility bills, but also just an open communication with everyone on the team at the plant. you know, the individual who manages the boiler, does it make sense we go through this many cubic meters a day? If so, how does that compare to the data? And all of this, it's always a living document. You're always meant to be verifying and understanding how that meter is operating.
Rajesh, I see your hand up.
Hello, can you hear me?
Yep.
Yeah. Hey, first of all, thank you for arranging this. This is a great things going on so far. Very interesting. I have one question for Dale. While he was presenting his stuff, I just quickly went on their website and just checked the stuff that what they are doing it or providing the things. I'm at the city of Mississauga, and we do have some metering and sub-metering. That is mainly for real time. We do the utility metering here or monitoring it, the data. For sub-metering, we do have for electrical side, which is kind of more easy to do the electrical sub-metering, but we are looking into the gas sub-metering, and I saw that there is some meters on the gas side. So my question to Dale is that, do you know anything about how we can have to do a sub-metering on the gas side, natural gas side?
Yeah, great question. Thanks for throwing it out there. Yeah, gas is a great thing to submeter. It's directly connected to your GHGs, Scope 1 emissions, a huge cost. And there are many ways to do it, just like there are many ways to meter anything else. Find a company that's hardware agnostic. They want to work with any meters and ingest it into their platform. So, there's Fox meters off the top of my head. Those are natural gas meters that you can install into those sublines. They're arguably the best value as far as easy to install and pull data from. Romet is another good example of getting sub-meters of natural gas in your natural gas lines. There's also kind of less costly proxies that you can use. And I'll give a very quick example. We had worked with two different clients, the exact same boiler system. They both wanted sub-metering of natural gas into their boiler.
Mm-hmm.
Understanding that problem and the pain point, again, like Plowman said at the beginning, defining what that is and what your end goal is, and saying that to your EMIS provider, you can go through a matrix and find the best fit solution to understand your gas usage. So one client spent about $10,000 on a Romet meter, installed it, got very accurate real-time cubic meters going into that boiler. The other company bought a less expensive 4 to 20 milliamp receiver, installed that in their boiler, and looked at their firing rate. It was a proxy to understand their natural gas use. And I give those examples because one is about 5x the cost of the other. But understanding what your client wants at the end of the day, do they need super accurate every last cubic meter metered? Or do they want, within 5% understanding how much natural gas is being used? So if you want a sub-meter, yes, there's sub-meters on the market. Like I mentioned, Romet and Fox, you can put in there and pull data off of. Or you can go out on a different route, a proxy with firing rate, temperature, or other sort of metrics.
Yeah, we tried with Onyx one, and it's working well. It's just it's too expensive, as you said, right? So
yeah, and that's where you lean on
yeah.
save on energy. So you get upwards of 50% off
Yeah.
of those meters now. And talk to Enbridge too. They've got good funding they really like to see their clients sub-metering natural
Right.
gas as well.
Yeah. Okay, great. Thank you.
And so you mentioned that you had steam meters. I've heard similar challenges of like costly metering steam. Was there a solution that worked for you? Like you had a number of those in your plans?
I would say we didn't have much challenges with the steam meters. They were installed, provided good data, and they were reliable.
We have another question in the chat from Deepak about hardware used for logging and making that bridge between, the sensors and the software platform and stuff like that. So, and if you want to comment on like your approach that you used, and then Dave and Plummet, if you want to follow up on that.
So I think it depends on the instrument itself and its like capability and compatibility. So I would say our electricians and integrators really advised on that. I just remember for the gas meter, there was a specific device that we had to install recommended by the gas company, some sort of data counter.
Okay, to
That's
help
all I
bridge
can
that
really
data on there.
call it.
Okay.
Yeah, that's from Enbridge. So they'll typically put a pulse output on your natural gas main, which then you can tap into and pull that data off of. If I understand the question correctly, I think the broad answer is that's the power of Industry 4.0 or industrial IoT. And that is where you're moving out of this world from a logger and then downloading data to into a world of real time, where you're pulling that data in real time, and every minute or 2 minutes you're delivering that packet to your platform to see in real time. You then kind of eliminate that hurdle of a logger downloading data and then uploading it through a CSV and onto a Excel spreadsheet. I don't know if that's the right answer, but that's the kind of the way I heard it.
Okay. And getting away from just the meters themselves in terms of the planning, I mean, you talked about that need to really spend that time up front to understand the problem you're trying to solve, what that looks like. What advice do you have in terms of like approaching that? Like, who should you be talking to in the organization? How do you start defining what you really want to get out of the EMIS?
Yeah, just talk to everybody that agrees with you and wants to spend money on EMIS. As simple as that. No, look for folks that would naturally experience an issue. So you're talking about a manufacturing facilities. Sometimes it's your maintenance folks. It's people that have power quality issues. A lot of energy savings measures that EMIS will point to, a lot of even employees can find out. So it's good to do as much research as you can with as many folks as you can before you actually take this project up to the head, so you have a clear understanding of the issues, because there's a lot of things that are kind of siloed out in between departments. So yeah, talk to your facilities folks, talk to your maintenance folks, talk to your general managers, talk to folks that have maybe looked at or implemented these systems before.
Okay. And then I think all of you sort of mentioned to some degree that like making the business case for this can be tricky because it doesn't have the same ROI of like installing a VFD or upgrading a chiller where you can do the calculations and be pretty sure that it shows up. You only save if you act on the data. What tips might you have in terms of having to like that you could use to justify that investment, because they can be pretty significant for an EMIS?
All right. I guess since I'm on unmute, I can take this one first, Jay. The thing to understand with EMIS is it really is the foundation, right? So you start taking on other energy conservation measures. Your EMIS system is the piece that will many times actually point you in the right direction. Without it, you may not find that measure, exactly like Dave said earlier, right? Like this is looking for the opportunities. So Nisa had a few examples too. And then once you take on in a conservation measure, especially ones that are funded by Save on Energy, you'll need some sort of monitoring and verification, which includes what was happening before this thing was done, when the measure took place, and what happened afterwards to verify the results, and you can get reimbursement or payment for that measure. So a lot of times, especially working with industries, large manufacturers, they would upgrade an expensive large piece of machinery, and there would be a custom track for rebates, and they'd have to do the monitoring and verification anyway. And I've seen folks go out and spend a lot of money for temporary metering that stays on site for 6 months just for the M&V portion. And that temporary price is typically, I don't know what the recent number is, but I want to say it's 30-40% of the price if you were to physically install something that's permanent. So there's a lot of value in having permanent infrastructure as your foundation.
Yeah, I'd echo that. And I would say, where do you start and where's the best ROI? Just look for your sore thumbs. Like go through your utility bills, your big machines, and what are you spending the most on now? And then ask yourself, what's our visibility on that? And if you're getting a junction of high cost and low visibility, that's where you start. Because as soon as you get that high resolution on a high cost item, you're going to find savings, almost guaranteed. And when you look at the cost, like Plowman mentioned, of a audit, which is kind of an older style of doing this, when you're investing a lot of money for the M&V and then you're removing all of that, versus just physically installing something forever, that cost of install is going to be a fraction of what you're probably going to save in a year with that high cost area.
Yeah, and I've seen permanent EMIS systems when they're properly set up actually be referred to as it's almost like an ongoing energy audit. So instead of paying somebody, 5, 10,000 to do like an ASHRAE level 2 energy audit, you have a system now that does this on a continual basis.
Yeah, and the really cool part of that is it tells the whole story.
Yeah.
Initially you're going to find a baseline flow or an unexpected very high usage. And the whole team, they know their plant best. Now they can see it in a new way. They're all going to agree, wow, this is an issue. We need to focus on this. Let's try implementing things to reduce that. And as we know, projects aren't A to B. You're all over the place, right? And so the great thing about a permanently installed EMIS is the data is going to tell that whole story. Oh, we tried these nozzles and they didn't work. So our water went up again. And then we tried this and went down again, but too far. And so over a 6-month period, it's all now data tracked. You have the beginning, you have all the middle crazy parts where you're trying new things, and then you have the end, and that whole story is told. And you can't achieve that with temporarily installed meters.
All right, I think we have time for one more quick question from Mahasa with your hand up.
Hi, Mahasa, he's here from Irving Tissue. Thank you. It was very informative, the presentation. It was mentioned about the demand spikes and how EMIS can help about that. Can you, I don't remember, I think it was Paulman who mentioned, can you please elevate on that as well, like a bit more details?
Yeah, sure. So with your demand charges, depending on how you're built, but if you're a large industrial, and I'm assuming Irving Tissue is, you're probably your monthly demand charge is based on your peak demand for that month. So that's the maximum amount of electricity that you use at any given interval. In most cases, that interval
Right.
is an hour. In some places, it's 15 minutes, right? If you have, let's say, access to 5-minute interval data, close to real-time data, you could start to chart out and you could see, from 8, 801, 805, 810, you can see exactly where your demand is. And oftentimes you'll find, or not oftentimes, but in some cases you'll find where that spike is something unusual and it happens once or twice a month, but it could be a 20% increase on your total demand. So it's really just about enabling the visibility to see those spikes in the making, seeing when they happen, and then once you have the data to see it, you can go back and figure out what actually happened on the floor, what is causing that spike, and then you can make a decision: is this something we can control?
So if I understand it correctly, because right now it is like we are a part of GA program and we have contractors, consultants to give us that data that we have access to. So what you're saying that these EMIS help us to connect that data coming from the IESO and like understanding on our side at the operation level, is that what EMIS does?
We've seen ones with global adjustment really use that to help measure how they're responding to those global adjustment, those peak day notifications. So, and if you have it in real time, you can see it's like as you're shutting things down, as you're ramping it down, you can see that demand dropping, and it gives you really useful feedback to help improve that performance on those peak periods. We do have to wrap it up. I apologize if there are still questions. Put them in the chat, and Dave, Anissa, and Clement can keep an eye on there as we're wrapping it up. There was also a request for, if you're comfortable giving contact information into the chat there, that would be great. A couple points to remind you, again, EMIS funding is available up to $250,000. Asia described this up front. If you have any questions, please do reach out to sem@ieso.ca. This is made available through Natural Resources Canada, a really great opportunity to get some powerful tools on your site. Additionally, through Save on Energy, there's one-on-one coaching available. So if you want to talk to an energy coach or someone about anything that we covered today, there's post-webinar support that you can follow up with, fill out the intake form. You can also sign up for a monthly bulletin, live training calendar, training support webpage. We have another panel discussion coming up this fall, other events on EMIS, other energy efficiency, energy management topics as well. So great to keep an eye out for those. If you are an energy manager working at a facility in Ontario, we have a peer community that you can join. All of these links are going to be dropped very quickly in the chat as I go through this, but you get access to online training, discussion forums, online discussion groups, things like that. So this is just for energy managers, not so much the vendors and consultants and utility people, but is a great opportunity to connect with peers. And lastly, the Energy Managers Playbook, Save on Energy's podcast, sharing great stories from energy managers. Season 1 is fully released on wherever you listen to podcasts. Some great talk about using data in some of those stories, and we are currently developing season 2. So if anyone has a great story, overcoming challenges within their organization around energy management, some successes they'd like to share with the community, please reach out to me at jay@goldfin.ca. And that's it for today. Thank you, everyone, for joining us. Thank you, Dave, Anissa, and Clement, so much for taking your time today. Appreciate all of the insight that you've shared and the great questions from the audience. So have a great rest of your week, and thank you all.
Thank you.
Thank you.
Thank you.